Guys, welcome back to TechDose, and in this video we will look at count of substrings containing every vowel and k constants 2 problem, which is from Leetcode number 3306. A good problem to solve after having solved this is maximum sum of distinct subarrays with length k problem, which is from 2461. I have already made a detailed video on this, so you can find the link in the description below after having solved this problem. In this problem you are given a string word and a non-negative integer k. Return the total number of substrings of word that contain every vowel a, e, I, o, u at least once and exactly k consonants. This means that all these vowel characters should have frequency greater than equals to 1 and there should be exactly k consonants. You have to find such substring. So a word can be considered as an array of characters, and if you consider this as an array of characters, then it is asking about find the total number of subarrays where all these the frequency of the vowels are greater than equals to 1 and there are exactly k consonants. Okay, so how you can solve this problem is you can take a word, like let's take the third example. You take a word and try to generate all possible subarrays. How many all possible subarrays can be present? So the subarray starting at index 0 and ending at 0, ending at 1, ending at 2, and so on till ending at n. So there will be n subarrays starting at 0. Similarly, there will be n minus 1 subarrays which starts at 1 and move to the right hand side instead. So you will find that there are a total of order of n square number of subarrays. So you generate all these subarrays, and then for every subarray you keep a track of frequency of the vowels a, e, I, o, u. And if the frequency of all these vowels are always greater than equals to 1 in a subarray, and you exactly have k number of consonants, then this means that particular subarray is actually valid and you can do a count plus plus for that. Okay, so this would be the simplest way to solve it. But if you look at the constraints, then it is saying about the word dot length is in the range of 5 to 2 times of 10 to the power of 5. Okay, and word consists only of lowercase English letters. Now if you look at this number, right, 2 times of 10 to the power of 5, if you try to generate all possible subarrays, which is n square, then you will end up with doing 4 times of 10 to the power 10 approximate operations, and you know this is very large as compared to 10 to the power of 8, which is considered to be 1 second standard. Okay, so our simple technique is definitely going to give you a TLE. It is not going to pass. Now why is this 5 significant in this case? Now the word length 5 is significant because our string length must be minimum 5, otherwise how can I have all these vowels, right? At least we should have every character of the vowel occurring one time, and therefore whatever is the valid window, at least the valid window will be of 5 size, and it should be of greater than equals to 5 size. Now whatever is the value of k, let's say the k value is 2, then the minimum size of a valid window should be 5 plus k. That is the minimum size of the valid window. If you have any window size which is less than this, any substring size which is less than this, then it will not be valid, because at least all these characters have to occur one time, and at least there should be exactly k constants. Therefore the valid window size should be minimum 5 plus k. Now why did I say minimum and not exactly 5 plus k? Because if you happen to see a window double a, e, I, o, u, and let's say there is a p, so p is a consonant, right? And if the k value was 1, then this entire thing would be valid, because a, e, I, o, u all are present. Yes, a is present 2 times, but the question actually mentions that each of the vowels should be present at least one time. Okay, it does not mention about whether you can have more times or not. You can have the vowels more time than one, right? And the consonant should be exactly k number of times. So here the size is it 5 plus 1 6? No, it is 7 here, because a is occurring 2 times, 1 2 3 4 5 6 7, right? But still it is valid. Even if I remove this a, then still it will be valid, right? Because it is a subarray and it follows the constraint. And that is why I said that the minimum valid window size must be 5 plus k, right? I think it is clear. Now let's look at some observation to solve it optimally. If you look at the validity check, all the vowels should occur at least once. This means that frequency of A, E, I, O, U should be greater than equals to 1. Now you should have exactly k consonants, so the non-vowels frequency should be exactly k, no more and no less. Now if you look at a window here, like a window means a substring, you call it as a substring, subarray, or a window, all these are same. Okay, now in this case, is it valid or not? So find the frequency of A, E, I, O, U. Are they all present? A is occurring one time, E is occurring one time, one time, one time, one time. So all the vowels are occurring, and at least they are occurring one time. And if you consider k value equals to 3, then yes, this entire window will be valid. It is valid. But if you change the k from 3 to 2, then this will not be valid. Okay, so it also depends on the k value. Now if you look at the second string which is given, and I'm asking about if the entire string is valid, then you check the frequency of A is 2, frequency of E is 1, frequency of I is 2, U is 1, and O is 1. So at least all of them are occurring, right? At least they are occurring one time. So the vowel is clear. Now think about the consonant. If the consonant count required was 2, then it will be valid. If the consonant count required was, let's say, 1 or 3 or anything else, then it will not be valid. So in this case, for k equals to 2, it will be valid. Now if you check out this slice, is this valid? Yes, it is valid, because the A's frequency will decrease by 1, but it is not removing A altogether, right? A is still present. Therefore, the vowel condition is satisfied, and there are 2 consonants, so k condition is satisfied. Therefore, this is also valid. Okay, so I think the validity is clear. Now let's see how to count the valid windows. Now in this case, you can start with 0 and go till 10. I mean, what I will do is I will be taking 2 pointer. The left pointer will be pointing to 0, the right pointer will be pointing to 0, and I will continuously move my right pointer to the right hand side unless all my conditions holds true. That means all the vowels are occurring at least one time, and the consonants are all also equals to the given k value. So in this case, k value equals to 3. I will show you in the dry run how to do that, but let's say that this is just a valid window that I have created from 0 to 10. Let's say this is a valid window. Okay, this is valid. You can check it out. I have already counted the frequency of each of the characters, which is 2, 3, 111, and you can look at the consonant counts as well. It is 3. Now you can check it by checking the frequency of all of them to be greater than equals to 1. How do you check the frequency? I mean, checking the frequency will require you to go to all the items and checking the frequency of each of the item. A better way to do that is take the map and find the size of the map. If you find the size of the map, and if it comes out to be equals to 5, then this means that all the entries are present. That means all the frequencies are greater than 0. If a frequency becomes 0, then you will be removing it surely, right? So that is why, instead of checking the frequency, you can check the size of the map. Fine. Now if you are thinking about why don't I take a set? So taking a set will create a problem if you happen to apply the 2 pointer technique, because if you move this left pointer to the right hand side, then you will require to reduce the frequency of some items, because you cannot remove this A altogether. If this L moves to this one, you cannot remove this A, because from L to R there may be some other A, right? And that is the reason you cannot remove it, and that is the reason you cannot use a set in this case. Fine. Okay, now once we have learned this, once we have learned the validity check as well, let's say 0 to 10 is a valid window. Now how to tell the number of valid windows which where 0 to 10 as a substring will be a part of it, okay? I can say that there can be multiple valid windows which starts with 0, and there will be multiple valid windows that can end at 10. So there are 2 parts of this problem. Whenever you find about the number of valid windows, once you have recognized that 0 to 10 is valid, then maybe there will be 1 to 10 which is valid, there may be 2 to 10 which is valid, right? So there may be multiple windows which ends at this 10 which will be valid, and also in the other way around, there can be multiple windows starting at 0 which can be valid, like let's say 0 to 10 is valid, 11, 12, 13, all these may be valid, right? So you need to add the two components, the valid windows starting at L and the valid windows ending at R. Now let's see how to count the valid windows starting at L. So starting at L, since you know that the condition is to maintain exactly k number of consonants. This should be exact in number, but the vowel frequency can increase. But the condition on the vowel is not very strict. It is just about maintaining at least one occurrence of each of the vowels, right? So once the condition is fulfilled here, even if you consider this window from 0 to 11, if you consider from 0 to 11, since 11 is a vowel, it will be fine because you are just increasing the frequency of vowel, but the consonant count is not changing. Therefore, this condition will be fulfilled. There will be no problem at all. Now check out the next item, 12. Again it is vowel, so there will be no problem from 0 to 12 because you are increasing the frequency of vowel. 13 will be fine, 14 will be fine, but 15 will be where you create an issue. Because if you include 15, then the consonant count will become 4, and so the window will become invalid because there is a strict rule of maintaining k consonants. So if I ask you about find the valid window starting at L, so if you know that 0 to 10 is valid, then the count of valid windows starting at 0 will be equals to, you can keep on extending this until you see the nearest consonant on the right hand side. Nearest consonant on the right hand side, okay? Because until you see the consonant, adding the vowel do not break the condition. Fine. So if you know that the nearest consonant is at 15, then you can do 15 minus 10 and you can say that there are 5 windows which are starting at 0. That is how you count it, right? So what I will do is I will be taking a counter and I will be adding 5 value. Okay, and once I have added this, I will not be moving this right pointer to the right hand side, but I will be adjusting this left pointer to the right hand side because there is another part to this question, which is valid windows ending at R. Okay, so all the valid windows starting from 0 I have counted. So maybe I will be counting all the valid windows starting at 1, right? All the valid windows starting at 1 and maybe ending at 10 and so on, right? So if I just move this left pointer, then it will automatically count all the valid windows ending at 10 as well, because 0 to 10 will be one result, maybe 1 to 10 will also be one result, right? So in this case, if I slide this to the right hand side, move the left pointer to the right hand side, then the frequency of A will decrease by 1, but still there is an A, right? So I will not remove this entry from the map. Now is it following our condition? The size of the map is 5 and the consonant count is exactly 3. So it is valid. 1 to 10 is valid, and since I have found 1 to 10 is valid, how many valid windows can I form? It will depend on where is the next consonant or the nearest consonant on the right hand side. It is at 15. So how many windows can you form starting at 1? 1 to 10, 1 to 11, 12, 13, 14. So again 5 windows you can form, and again you slide this to the right hand side, and you have lost E, so you will be decreasing the frequency of E. E's frequency has not become 0, so I will not be removing it. Okay, now once you have reached to this 2, again you check it is following the condition. The consonant count is still 3, the size of the window is still 5, right? So now I will be checking for all the valid windows starting at 2, and again you can say that it will be 15 minus 10 because 2 to 10 is valid and the next consonant is at 15. So again 5 valid windows will be added. Again you slide this and E's frequency will become 1. Again you check that the number of entries in the map is 5, so 3 to 10 is also valid. Again another 5 will be added because 3 to 10, 11, 12, 13, 14 will be valid, right? Again you slide this to the right hand side, the frequency of A will become 0, so this entry will be removed. And as soon as this entry is removed, then you know that the size of the map will become 4, it is not 5, and that is why it will be invalid window. So 4 to 10 becomes invalid. As soon as that happens, then you move this R to the right hand side. And when you see a new item, if it is a vowel, you just increment the frequency. If it is not present in the map, create a new entry in the map. Okay, so this is the process in which we will be trying to use the 2 pointer and trying to create variable size sliding window, where I will always be trying to find starting at L and ending at R, I will keep moving this R to the right hand side until I find a valid window. And if I have found the valid window, then I will keep moving this L to the right hand side until I find an invalid window. And within the process, I will try to add up the valid window starting at L and the valid windows ending at R, and that will be incorporated with this technique. Okay, so I think the idea is clear. Now I will show you the dry run, but before doing that, if you have to always find the next consonant, then you might have to iterate. So just to avoid iteration, I will be trying to pre-calculate all the next consonant. How to do that? Given the word, in this case, I will be taking an array next consonant of the size of the word. Okay, so this will be having a space complexity of order of n, right? And what I'll do is I'll assume the next consonant is at 18. Okay, and I will be iterating from right to left. So when I am at P, then I will write as the next consonant being 18. And if the current character is actually a consonant, then my next value will be updated to the current index 17, and I will move to the left hand side. So for this I, the next consonant will be 17. Is it a consonant? No. These three are not consonants, so for all of them you will be writing 17. Now you will be at U. Again, this is not a consonant, not a consonant, not a consonant. So 17, 17, 17. Now you are at this 9. So for this, the next consonant is again 17, but this is a consonant, so this will be updated to 9. Okay, move to 8. For this, the next consonant is at 9, but this is also a consonant, so update this to 8. For this, the next consonant is at 8, but this is also a consonant, so update this to 7. For all this, from 6 to 2, you can say 7 is the consonant, right? 6 to 2, 7 will be the consonant. As soon as you reach to 1, 7 will be the consonant, but since this is a consonant, you will be updating this to 1. Go to the left side, C. 1 is the next consonant, you can write 1 and that's it. You are done. So this is how you can pre-process, you can pre-calculate. This will help us count the number of windows faster, because if I say later that, from 2 to 12 there is a valid window. Now you will be ending up counting, okay, if 2 to 12 is valid, then tell me how many valid windows are starting from 2. Then you can say that the next consonant is at 17. So I can subtract 17 and 12 and say that there will be 5 valid windows starting from 2 and ending at 12, 13, 14, 15, 16, right? Okay, so that is why 5 will be added. And that is the reason pre-calculating always saves time. Fine. Once we are done with this, let me do the dry run. So we will be solving it by tracking the valid window using the 2-pointer technique. So this is also a variable size sliding window technique using 2-pointer. So I am taking the same example as the previously pre-calculated next consonant example, right? And I have already pre-calculated the next consonant. It is the same. Now for this case, I will be maintaining a map, a frequency map, which will be tracking each vowel's frequency, and I will be having a consonant counter. My K value is already 3. I will be counting the total number of windows, the valid windows that I am seeing, and the L and R pointer. So you can imagine that this will be the R pointer and the L pointer initially pointing, and there is a previous pointer as well. So this is a variable that I have taken in my implementation, so that if the right pointer is not moving to the right hand side, then I don't end up changing the frequency. Okay, so you may have your own implementation where you will not have this previous. It is just in my own implementation, right? So let me just try to explain. So the previous is here at index -1. We will keep moving this right pointer to the right hand side unless our consonant count is not exceeding beyond this K, or otherwise we have not found a valid window. Until then we will be moving it to the right hand side. So if we see a consonant, our consonant count will increase by 1 and you move to the right hand side. And when you move, your previous will also get updated. Okay. Now since the right and previous are not the same, you can keep moving it on the right side. So just to maintain the simplicity in this dry run, I will not be updating the previous all the time, right? So in this case, again, D is a consonant, so you update the frequency of D. A is a vowel, so you just create an entry for it. Again, E is a vowel, so create an entry for it. and again this E is a vowel, so increment the frequency for it, right? Now what is the size of it? The size of it is 5. You know that if the K value is 3, you know, if all the vowels have to occur, at least 5 characters have to represent all the 5 vowels, one for each, and the K value being 3, your valid window size should be minimum 8. So until you reach to this 7, you cannot see a valid window. So that is why I will not do anything but just keep incrementing the frequencies until I reach to this index 7, right? So I'm done with this E. I will again be seeing A, increment the frequency of A, again C and E, increment the frequency of E. Now I am seeing a P and the consonant count becomes 3. Only when I reach to index 7, starting from here, I can have a valid window, because the number of characters between L and R that we have covered is actually 8, minimum 8, right? So now you check the size of the map. Size of the map is not 5, so we have not found the valid window. Is our consonant count greater than K? No. So we are fine. We can keep extending this right pointer to the right hand side. If you see a K, then the consonant count becomes 4. Now again you check. The size of the map is not 5, and also the consonant count has been greater than 3. So this means that I need to remove a consonant from the left side and move your left pointer to the right. And once you move, if the last item was a consonant, decrease the frequency of that. So now the left pointer is at index 1, right pointer is at index 8. Now you move your right pointer to this B. Again a consonant is coming, increase the consonant count. Now again check if it is a valid window. Size of the map not 5. Okay, so this is not valid. And you check that the consonants are also greater than K. So that means you have to move your left to the right hand side, and you have to decrease the frequency of this consonant. So this will become 3. Now your left pointer is pointing to 2, right pointer is at 9. Move your right pointer and include this I. So I has occurred one time. Again this is not a valid window, even though the consonant count is same as K, but the size of the map is not 5. Move this to the right hand side. O has an entry with a frequency 1 now. Again the size is not 5, so this is invalid. But the consonants are less than equals to K, so you don't need to move the left pointer. Now you move the right pointer to U. Okay, once you reach to U, U creates one entry with frequency 1. Now you check, is it valid from 2 to 12? You will see that it is valid, because the frequency here, I mean the size of the map is 5 and the consonants have 3 count, which is exactly equals to K. So since this is valid, how many valid windows will start at 2? You can say that it will depend on the next consonant. So look at this 12. Where is the next consonant? It is at 17. So how many windows can you form starting from 2? You can form 17 minus 12, that is 5 windows. Okay. So the count will be appended by 5 value. It will be adding 5 value simply, right? And then you move the left pointer to the right hand side, because there may be other windows which are valid and ending at 12, right? So if you move it to the right, since A is a vowel, its frequency will reduce by 1. And since A's frequency has not become 0, so we will not be removing it. Is this valid? Yes, the size of the map is 5 and the consonant count is exactly equals to K. So this is also valid from 3 to 12. How many windows will be starting at 3? It will depend on the next consonant at 12, which is 17. So 17 minus 12 will be 5. So 5 will be added to the count. And again, you move this to the right hand side. So your E's frequency will reduce by 1. But since this frequency is not 0, I will not be removing E. And again 4 to 12 is valid, because the size of the map is 5 and the consonant count is 3, exactly equals to K. So how many windows will be starting at 4? It depends on the next consonant at 12, which is 17. 17 minus 12, which is 5. So add another 5 for it. And move your left pointer to the right hand side, and E's frequency will again reduce by 1. So E's frequency becomes 1. Okay. Now you check if it is again valid from 5 to 12. Yes, it is valid, because the size of the map is 5. So there are 5 unique entries and consonant count is exactly K. How many windows are there? Depends on the next consonant at 12. So 5 more windows which are starting at 5. So move to the right hand side. Once you move to this index 6, you will reduce the frequency of this A, so this becomes 0. And since the frequency becomes 0, I will be erasing it from the map. Now you check, is this valid from 6 to 12? Find the size of the map. No, it is not valid, because the size of the map is 4. There are only 4 entries. Okay. Now since it is invalid, move the right pointer to the right hand side. And once you move, you see what character are you seeing. So you are seeing A. And if it is not present, create an entry because it is a vowel with frequency 1. Now you check if it is valid from 6 to 13. You will say that yes, it is valid because there are 5 unique entries in the map and the consonant count is exactly K. So you will find out how many windows will be starting at 6. It will be the next consonant at 13, which is 17 minus 13, which will be 4. So add 4 for this. And then you move this to the right hand side. So E's frequency will decrease by 1. So this becomes 0. Remove this entry. Now you check, is this 7 to 13 valid? No, because the size of the map is 4. So now you move this right pointer to the right hand side, which is E. Now once you append this E, its new entry will be made and 1 will be appended. So the size is 1, 2, 3, 4, 5. Okay. So is this 7 to 14 even valid? And the answer is yes, because the size of the map is 5 and the consonant count is same as K. So how many windows will start at 7? It will be next consonant at 14, which is 17 minus 14, which is 3. So add 3 for this and move this to the right hand side. Now since you are losing a consonant count will decrease by 1. Now is this valid from 8 to 14? No, because the consonant count is less than K. So you move this to the right hand side. E's frequency is increasing by 1. Is it valid from 8 to 15? No, because the consonant count is less than K. Move this to the right hand side. I's frequency will increase by 1. Again it is invalid because the consonant count is less than K. Again you see a consonant, so increase the consonant count by 1. It will be 3. So now is it valid from 8 to 17? Yes, and it will depend on the next consonant at 17. 18 minus 17, which is 1. So add 1 for this. Okay, and then you move it to the right hand side. You are losing a consonant K, so decrease the consonant value, it becomes 2. Now you move this right pointer to the right hand side and you have ended. So the total count that we have got is 5, 5, 5, 5, which is 20, 24 and 28. So 28 will be the total count using the 2-pointer sliding window approach. Okay. So this approach involved pre-processing using the next consonant, that means the nearest consonant on the right hand side, to make our counting easy for the count of sliding windows, and therefore the space complexity is order of n due to the next consonant pre-processing array, and the time complexity is n for pre-processing and n for sliding window using the 2-pointer, and that is why the time complexity is also order of n. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, there are utility function is vowel, which will be returning given a character if it is a vowel or not a vowel. Then this is the pre-processing function which will be finding the next consonant for the entire word. Okay, so you can just go through it. I have already explained it in the dry run. Now if you go to the count of substrings, it will be getting a word and the value K. So find the size of the word. Then the next consonant will be the one which will be saving the position of the nearest consonant on the right hand side, and this is the pre-processing function call. After that we will be taking the counter, the consonants count, the map which will be taking the each vowel's frequency, then the left right pointer for applying the 2-pointer technique to track the valid window, and then this is a extra variable that I have taken just to maintain that if there was a valid window from let's say L to R, if it was valid, and if you happen to move this left pointer to the right hand side, then this R will remain at the same position, so we don't add up increasing the frequency of this right all the time, or the consonants where the R is actually pointing. It should not be increasing all the time, right? So just to take care of this condition, I have taken a previous. Okay, so whenever the right pointer moves to the right hand side, the previous will be assigned to the previous value, I mean the new value, you can say, right? So at whatever position the right is present, the previous will be assigned to it, as you can see here. And if in the process the right becomes right plus plus, then again you will have to increment the frequency for this new item, right? So just to take care of that, if you do the dry run, I think it will be clear, but you should try to implement it yourself too. Now this is the loop which will be running for the entire string, and this is the condition that if the right has actually moved by one position to the right hand side, then we have to increment the frequency of the vowel if the new character is a vowel, otherwise increment the frequency of consonants, and then the previous will be assigned to this the new index of the right. Okay, so this previous helps us to always make the update happen whenever the right pointer moves to the right hand side. Okay, now if you consider this case, if statement, this is saying that if the right pointer is pointing to an index which is 5 plus k minus 1, at least this, to an index greater than equals to this, it means that you must be seeing a valid window. Okay, so this is the processing for the valid window. If you don't see a valid window, then I will just continuously keep moving to the right hand side because of the insufficient window size. Fine. Now once we are done with that, if your window is valid, then what has to be done? It will be checking if the vowel frequency size is 5. That means you have all the entries for A, E, I, O, U. Okay, so if you have all these entries present and if the consonant count is also k, that means you have found a valid window. And if you have found a valid window, then you know, if you are at L and if you look at R, then you have to add the number of windows that will be starting at this given index L. Right, given index L, and that will be equals to the next consonant at R, which will be at, let's say, C. You can just subtract C minus R, and that is what it is doing. Next consonant at right minus right. So that value has to be added to the count, and this will give you all the windows that starts with L and is valid. Okay, now once you have done this, then you have to check the if statement here. If the entries are 5 in the map and the consonants are k, that means you are seeing a valid window, and you have actually added the count of valid windows starting at L. Then you will do L plus plus and shrink the window, right? So that is what we are doing. We are shrinking the window. We will be checking if the current character that we are losing here, character C that we are losing here, is it a vowel or not a vowel. If it is a vowel, then I will decrease the vowel frequency, and if the vowel frequency becomes 0, I will be removing that entry from the map. Okay, otherwise if it was a consonant, then just decrease the consonant counter. Fine. That is how you will be moving the left pointer to the right hand side, and this left pointer will also move to the right hand side if you see more number of consonants. If there are more consonants from L to R, then you have to stop and move this left pointer to the right, unless you again bring back the consonants to be less than equals to k, right? So in these two conditions, your left pointer will be moving to the right hand side. Now if these two conditions do not hold true, then the left pointer will not move to the right hand side, but the right pointer will only move to the right hand side. So we will be expanding the window, right? So this problem may be a little bit complex, so it comes on the more complex side of the 2-pointer sliding window technique, but I think if you apply some effort and use your notebook, you should be able to solve this. If you still have any problem, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.